Hello, this is question 2 from the MAT Specimen A paper from 2009. So show with working that all of that thing with lots of coses and sines is equal to that thing with lots of coses and sines. Right, so I suppose if I just expand out the second one and show us the top one, then everything's looking good. Right, this is going to be a nightmare on a screen this size. So I'm going to do C's for coses and S's for sines to save a bit of space. So I'd have to put that up here. So let's see, equal cos theta and S equals sine theta. Then I can just go off of here. Otherwise I'll never fit all this on. So I'm going to have an x cubed, and then I'm going to have a minus c plus s x squared. Then I'm going to have a c s x, then a minus x squared, a plus c plus s times x, and a minus cs. So does that look exactly like what I've got at the top? So I just need to rearrange it into the same order essentially. So I've got an x cubed, so that's great. My x squareds, I've got they've made it a minus at the start, so I'll have a c, oh these are all minuses, so a c plus an s plus a 1, so 1 plus c plus s times x squared, so that's dealt with those. Then I've got a cs plus a c plus an s, so that's the same. So a cs plus c plus s, and then minus a cs, or as they put, an sc. So that's exactly what we want. Deduce that the cubic in 1 has those roots. So, well, they've given us that root for the 1, so I just need to factorise again. So I can factorise this bit and say, well, that is equal to x minus 1. Well, I mean, they've told us what it's going to be. It's going to be x minus, actually put in cos theta that time, and x minus sine theta. And you can see that's what it comes out as if you expand it, so that's fine. So therefore, roots of 1 cos theta sine theta. So, right, that was a pretty easy starter. Part 2, give the roots when theta is pi by 3. Right, okay, they're not asking for much there then. So it's going to, well, 1 isn't going to change. So cos is going to be a half, and then that one's going to be root 3 over 2 for sine. So that was also pretty straightforward. So part 3, find all values of theta in the range 0, including 0, up to 2 pi, not including 2 pi, such that 2 of the 3 roots are equal. So we need then that, so if 2 of them are the same, we need cos theta is equal to 1, sine theta is equal to 1, or that cos theta is equal to sine theta. They're our permutations. So cos theta we can include 0. So that's going to be fine, but we can't include 2 pi, so we've got 0. Sine theta being equal to 1, that's just going to be at pi by 2. And then these things are going to be the same at, well, pi over 4 is one of them, and then pi on from that. So 5 pi over 4. So they're our values. Oh, this is really storming through, isn't it? So part 4, let's go to blue just for the last part. What is the greatest possible difference between the 2 roots? And what is, well, 2. And for what values of theta in that range does that difference occur? So the greatest possible difference is 2. Greatest possible difference equals 2, because we got 1. That's just staying at 1. And the others can get to minus 1. So for what values then are we going to get minus 1? So that's going to be, we get minus 1 for cos at pi, and we get minus 1 for sine at 3 pi over 2. So well, that's not asking for much either. Show that for each such theta, the cubic that's the same, right? So whichever one we put into here, we're getting the same thing then. Okay, so if theta is equal to pi, then 1 gives us, we've got x cubed, and then we've got a takeoff, so we've got 1. So if theta is pi, this is where we're getting our minus 1 for cos. We're getting 0 for sine, so that's killed off the x squareds. Then that's going to be a 0. Then we're going to have a minus 1 plus a 0. and then we're going to, that's times x, and then we're going to have plus another 0. So that is x cubed 0, 0 minus x. Okay. When theta is equal to 3 pi over 2, that gives, well, we know it's going to give the same thing. So here we're getting a 1, a 0, and a minus 1. So 1 plus 0 minus 1, so that gets rid of our x squareds. Here we need to have something hang on, but that's going to be a 0 plus a 0 minus a 1, and then plus a 0, which is x cubed minus x. And that, believe it or not, is the whole question, which is a bit of a yawn of a question, really. But hey ho, that's question 2 done.